In this video, we're going to take a look at exam revision for the Central Limit Theorem. So what we're going to do for this video here today is take a look at 3 exam style questions on the Central Limit Theorem. And as you can see, these are based on the following topics. So we're going to take a look at using the Central Limit Theorem as well as applying the Central Limit Theorem to other distributions. So as always, pause the video, have a go at the questions as they appear, and then double check that your solution matches what we get on the screen. So that gives us everything that we need then for our introduction to this video. Let's get started with question 1. Starting off with question 1 then, where we have a sample of size 30 that's taken from a population with an unknown distribution with mean 20 and variance 10. Now for this question, it asks us to find the probability that the sample mean is greater than 21. Now we can't start here by defining this situation with a random variable because we don't know the original distribution. As it says here, it comes from an unknown distribution, okay? However, we do know the mean. So the mean here is given as 20 and the variance is 10. So we've got everything that we need here now to use the Central Limit Theorem. So let's just note this here then. So using the Central Limit Theorem. So CLT here just means the Central Limit Theorem. In that case, then the sample mean here, x bar, this will be approximately normally distributed then with a mean here of 20. And then for my second parameter here, this will be the variance 10 divided by the sample size, which is 30. So we get 10 over 30 there, or 1 over 3, whichever you prefer. Either's fine. And then what we're looking to find here is the probability that the sample mean is greater than 21. So we're looking for the probability that x bar, the sample mean, is greater than 21. Okay. And to find this probability here, we're going to simply use our calculator. So we go into stats mode, distribution, normal, and then NCD here because we're using the Central Limit Theorem and we get this approximate normal distribution. Okay, so NCD here, and it asks us for a few different things. So it asks us for the data type, which is a variable. I'll just shorten it to var just to save a little bit of time. It then asks us for the lower and upper values. So lower and upper. And it also asks us for sigma here and mu. Okay. Now, because we're looking for the probability that the sample mean x bar is greater than 21, we put 21 as the lower value. And then for the upper value here, we pick an arbitrarily large value. So I just put a load of 9s. Something like this is absolutely fine. So something like that would suffice here. So let me just do that as well as I go. So 21 for the lower, a load of 9s there for the upper. Now for sigma, well, that's going to be the square root then of 1 over 3. So don't forget, this is the variance here. So we want the standard deviation. So we take the square root of this here. So that's the square root of 1 over 3. And then for mu here, that would be 20. So if I input those as well, the square root of 1 over 3, and then 20 then for mu, input those, and what I get here then, if we do this correctly, so the probability that the sample mean x bar is greater than 21, this is equal then to 0.0, so 0.0416 there. Okay, that's 3 significant figures there, and that gives us the solution to question 1. Moving on to question 2 then, where we have a local hospital that receives on average 10 calls every minute. Now for the first part of this question, then part A, all we're looking to do here is find the probability that in one 50-minute period, the hospital receives no more than 450 calls. So for part A then, the very first thing that I'm going to do here is define a random variable to model this situation. Okay, so if I choose x then as my random variable, x will follow a Poisson distribution with parameter of 10. Okay, and this is for a 1 minute period, as mentioned here, every minute. So this is for a 1 minute period. We'll make a note of that here. So 1 minute period. Now, if we actually read this part correctly, then what we're looking for here is the probability in a 50-minute period. So in that case, then, If we start with a 1 minute period and we need a 50-minute period, then clearly we need to scale the parameter up. So if I choose now a new random variable to model the new parameter then, so for example, if I just choose y here, y will also follow a Poisson distribution with my parameter now being 10 times by 50 because we're looking at a 50-minute period. So 10 times by 50 gives us a parameter of 500, like so. And as mentioned then, this is for a 50-minute period. So we'll make a note of that as well. Like so. And then what we're looking for here is the probability that our random variable y here is less than or equal to 450. Okay. Now clearly to evaluate this probability here, we simply use our calculator. So if I do this, we go into stats mode, distribution, Poisson, and PCD. And it asks us for two things here. It asks us for x and mu. So x in this case is this value, which is 450, and then mu would be this parameter here of 500. So if you input both of those and press enter, what we get here then is 0.0124. So we get 0.0124 there. Okay. And there we have it. So that is the solution to part A. Hopefully nice and straightforward just to get us started. Now for part B, this is where we now use the central limit theorem. So for part B then, as it says here, using the central limit theorem, estimate the probability that in one 50-minute period, the hospital receives no more than 450 calls. So pretty similar to the first part then, but now just using the central limit theorem. So where do we start then? Well, we know from part A that the mean and variance here for the number of calls every minute would be 10. Okay. So let's go back to this distribution here. So we've got x, which follows a Poisson distribution with parameter of 10. So the mean and variance, so mean and variance is equal to 10 because it's a Poisson distribution. So this is because this is a Poisson distribution. Okay. So from here then, we can now use the central limit theorem because we've got the mean and variance. So using the central limit theorem. So using the central limit theorem. So CLT just means the central limit theorem here. Then in that case, the sample mean, x bar, would be approximately normally distributed then with parameters of mu, which in this case would just be 10. And then for the variance here, we need to be slightly careful. Remember, this is 10 divided by the sample size, which in this case would be 50 because we're going to take 50 lots here of a 1 minute period. Okay, so we get 10 over 50, like so. And as we mentioned then, for a 50-minute period, so let's just write this down here. So for a 50-minute period, this gives us 50 times x bar. Okay, like so. So what I'm looking for here then is the probability here that 50 x bar, so 50 lots of the sample mean here, 50 lots of x bar is less or equal to 450. Okay. So what I can do here then is divide through by the 50. And in that case then, dividing through by 50, we get the probability that x bar, sample mean, is less than or equal to 9. Okay. And then to evaluate this probability here, we can simply use the normal distribution on our calculator. So again, we go into stats mode, distribution, normal, and NCD. Okay. And it asks us for a few different things here. So it asks us for the data type, which in this case, again, it's just a variable. So data is a variable. Okay, I'll just abbreviate that or shorten that to var. It asks us for the lower and upper value. So lower and upper. And then it also asks us for sigma and mu. So let's start then with the lower and upper value here. So now, because we're looking for the probability that x bar is less than or equal to 9, what we do here is we put the 9 as the upper value. So we put 9 as the upper value. And then for the lower value here, we put an arbitrarily small value. Remember, I just put minus and then a load of 9s. Okay, something like that is absolutely fine. Now for sigma here, just be careful. It's not going to be 10 over 50 or 1 over 5. It's going to be the square root of that. Okay, so it's the square root of 1 over 5. And then for mu here, that would simply be this parameter of 10. Input those and press enter them. And if you do this correctly here, then what you should get is, so actually let me just write down what you should get here. So that's the square root, as we mentioned, of 1 over 5. And we also have mu equals 10. So let me just double check that I've done this correctly then. So my lower is a load of negative 9s here, like so. Upper is 9. We then have the square root of 1 over 5 and 10 for the mean. And then if you do this correctly, then press enter. What you should get is 0.0. So 0.0127 here. And that is two free significant figures. And the good news is this probability here is close to the original probability here. That's what we'd expect, right? This is an approximation, but they should be pretty close. If they're not, something's gone wrong. Okay, either we've got a very small sample size, in which case the central limit theorem doesn't really hold, or we've made a mistake somewhere in our preliminary working. Okay, so there we have it. That gives the solution to question 2. And to finish with here then, let's take a look now at the very last question, question 3. So for question 3, we have a random sample of 100 observations that's taken from the random variable x here, which follows a negative binomial distribution with parameters of 10 and 0.25. So for this question here, it asks us to estimate the probability that the sample mean is less than 38.5. So the first thing that we need here is the mean and variance of our random variable x. Okay, so we need the expectation of x. So we need the expectation of x, and we also need the variance of x. Okay. So for a negative binomial distribution, the expectation of x, the mean of x here, this is equal to r divided by p. Okay, so we get r over p there. So we'll come back to calculating that in a moment. Then for the variance here, this is equal to r times 1 minus p all over. So r times 1 minus p all over then p squared. Okay. So let's calculate these then individually. So r over p here, well, that's going to be 10 divided by 0.25. So we get 10 over 0.25. So that's the same as 10 over 1 over 4, which is the same as times in 10 by 4. So that gives us 40 there for the expectation of x. And now let's calculate the variance of x here. So that's going to be equal then to 10 times 1 minus here 0.25. And then we divide this here by 0.25 squared. Okay. So if you just put this into your calculator then, what do you get here? If you do this correctly, what you should find then is you get 120. Okay. So we now have the expectation of x, the mean, and we also have the variance as well of x here. So we've got everything that we need now to use the central limit theorem. So now, using the central limit theorem, again, I'll just abbreviate this to CLT. Okay. Then the sample mean, x bar here, will be approximately normally distributed with parameters then of the expectation of x, the mean here, which is 40. And then for my second parameter here, this would be the variance divided by our sample size. So that's going to be 120 over 100, like so. Now from here then, what we're looking for is the probability that the sample mean is less than 38.5. So what I'm looking for then is the probability that x bar, our sample mean, is less than 38.5. Okay, like so. And to evaluate this here, we just use the normal distribution here because we've used the central limit theorem here to be able to get this approximate distribution. So we go to our calculator here then. We go into stats mode, as always, pretty much, distribution, normal, and NCD here. And again, it asks us for a few different things. So what does it ask us for? Well, it asks us for the data type, which in this case is a variable. So variable here. It asks us for the lower and upper value. So lower and upper. It asks us for sigma, and it also asks us for mu here. Okay. So in terms of the lower and upper here, well, we're looking for the probability that the sample mean x bar is less than 38.5. So that means we put 38.5 as the upper value. And then for the lower value here, we pick an arbitrarily small value. So I just put minus and a load of 9s here. Something along those lines is absolutely fine. Now for sigma here, the standard deviation, well, that would be the square root of this here. Remember, this is the variance. So if we want the standard deviation, we take the square root of this. So the square root then of 120 over 100. And then for mu here, that would simply be this parameter then of 40. Okay, so let me just input those as well. So 38.5 for the upper value. For sigma, that's just the square root of 120 over 100. And then for mu, that is 40. Input those. And if you do this correctly, then what you should find here is you get 0.0. So 0.0 here, 855. Okay, like so. And there we have it. So that gives the probability that the sample mean is less than 38.5. And that gives us the solution there to the very last question, question 3. And that actually brings us to the end of this video on exam revision for the central limit theorem.